Tan.
And I'm Arpit Kamdar, and this is the physics of basketball.
The first thing we're going to talk about are Newton's 3 laws. The first law is inertia. Inertia states that an object will stay in constant velocity in the same direction unless an outside force acts upon it. To demonstrate, I'm going to pass the ball to Arpit. Arpit, why didn't you catch the ball? Now you're going to have to get it. Alright, let's try this again. Well, Arpit, you changed the direction, you just didn't stop the ball. Alright, Arpit, last time. As you can see here, the ball was moving at a constant velocity, but Arpit was the outside force which helped stop the ball.
Alright, now we're going to talk about Newton's second law, which states that the force is directly proportional to the mass and acceleration of the object. Meaning, if it has a higher mass or a higher acceleration, the force will be greater. These two tennis balls have a very low mass, so they'll have a very low force. This basketball, however, has a lot higher of a mass. So it has a lot higher of a force too.
The last law is Newton's third law. Newton's third law states that for every action, there's an equal and opposite reaction. Notice that when I'm dribbling, the angle at which the ball hits the ground is the same at which it bounces off.
Another example of Newton's third law is when you hit the ball off of the backboard to get it into the basket, also known as a bank shot. Notice when I shot that free throw, the ball had backspin on it. Backspin makes the ball bounce in an opposite direction when it hits the rim or backboard. This gives the ball a higher chance of going in.
The next thing we're going to talk about is projectile motion, more specifically, horizontal launch.
Horizontal launch is exemplified in basketball through a chest pass.
The velocity in the y direction is 0. However, that changes over time due to gravity, which has an acceleration of -9.8 meters per second squared.
The velocity in the x direction remains constant, so its acceleration is 0.
To find a change of x or change of y, simply measure the distance that the ball travels.
And that is horizontal launch. Another example of projectile launch is angled launch, which is exemplified in basketball through a shot. Angled launch is the same as horizontal launch, except the ball is shot at an angle rather than horizontally. So it does have an initial y velocity.
To solve for the unknown components of projectile motion, simply use the kinematic equations. Last but not least is the law of conservation. The law of conservation says that a ball dropped from this height should bounce back to the same height. Evidently, however, that doesn't happen. This is because energy has lost their heat when the ball hits the ground. Therefore, to keep the ball bouncing, a force must be applied every single time when the ball is dribbled. And that is the physics of basketball.